Problems based on compound proposition. First problem, let P is a circle is a conic. Q proposition is square root of 5 is a real number. R representing exponential series is convergent. Express the following compound proposition in words. So whatever the following propositions they have given, based on that logic connectives, we have to express those in terms of words. So the first one is P conjunction of negation Q. What does P have? A circle as a conic. Write down the same. A circle as a conic. As we have conjunction here, you have to insert the word and. Q is square root of 5 is a real number. Since here it is a negation Q, you have to say as root of 5 is not a real number. This statement is equivalent to P conjunction of negation Q. Next problem. Negation P disjunction Q. P is a circle is a conic. So negation of P will be a circle is not a conic. Since we have disjunction here, insert the word or. Q have to write the same statement. Square root of 5 is a real number. Let us go for the third one. P exclusive disjunction of negation Q. So here, since you are using the exclusive disjunction, you have to use the word either and or in the appropriate places. So your P, before P, what you have to insert? You have to insert the word called as either. Either circle is a conic or square root of 5 is not a real number. Since we have negation of Q, but both it cannot be, but not the both. Next, let us go for the next problem. Q gives you negation P. If Q, then it gives you negation P. So what we have to do here is, if square root of 5 is a real number, then a circle is not a conic. Since we have here negation used, not. Next one. P gives Q exclusive conjunction R. So when you have this arrow mark, we have to use if then in the appropriate places. Also, you have to use either and or here, but not both. So if then, if a circle is a conic, then either square root of 5 is a real number or the exponential series is convergent, but not both. It means the same. Negation P biconditional Q. Here you have to use not for P, negation P and Q. So biconditional means it must be if then only if. So what we have to do is, if a circle is not a conic for negation P, till here it is about negation P, then square root of 5 is a real number, and if square root of 5 is a real number, then circle is not a conic, because negation P, if negation P then Q, if Q then negation P. That is what our definition says. Next problem. Construct the truth table for the following compound proposition. When they give the proposition, you have to construct using the truth table. So first one is P conjunction negation Q. Here two variables are used, P, Q, and also we require negation Q. Since we have so many, all the four are based on P, Q and negation P, negation Q also. So we have taken P, Q, negation P, negation Q, and whatever the problems they have given, we have substituted here. Okay. So 0, 0, 0, 1, 1, 0, 1, 1. These are the values generally we'll check for the truth values. So the negation P gives you the opposite of your P. If it is 0, will give you 1. 0 means 1. 1 will give you 0. 1 will give you 0. Negation Q, if it is 0, will give 1. 1 means gives 0. 0 gives to 1. 1 gives 0. First problem is P conjunction of negation Q. So in this problem, we will check only for P and negation Q. So 0, 1 gives you 0. Conjunction, remember we have to do some kind of multiplication. 0, 1 gives you 0. 0, 0 gives 0. 1, 1 gives 1. 1, 0 gives 0. Next problem is negation P or Q. So we have to check for negation P or Q. First, if it is given negation P or Q, you have to first consider this one, then only you have to consider this one. So 1, 0 gives you 1 since it is a disjunction. 1, 1 gives you 1. 0, 0 gives 0. 0, 1 gives 1. P, if P then negation Q. This is conditional. So we have to consider P negation Q. Remember, when P is true and Q is false, then only it is false. In all other cases, it will be true. So 0, 1 gives 1. 0, 0 gives 1. 1, 1 gives 1. 1, 0 gives 0. Next one is negation P exclusive disjunction of negation Q. So negation P exclusive disjunction of negation Q. So only these two we will be considering. So as per our definition, either of the things should be true but not both. Either both are true, both are false means it will give you 0. Either of the statement can be true or false. So here 1, 1 it is same, since it will, therefore it will give you 0. 1, 0 will give you 1. 0, 1 will give 1. 0, 0 will give 0. Now let us discuss the third problem. Let P, Q and R be the propositions having truth values 0, 0 and 1 respectively. Find the truth values of the following compound proposition. So from this problem we can get to know that the P's truth value is 0, Q is 0, R is 1. Okay. The first problem is P or Q or R, meaning it is P disjunction Q of disjunction R. What we have to do is, so substitute the value. P value is 0, Q value is also 0, R value is 1. So we have substituted here. Zero, 0 gives you 0. As per this symbol, we have to do is disjunction. 0, 0 will give 0. So then you carry this down, or disjunction 1. 0 disjunction 1 will give you 1. So now let us move to the second problem. P and Q gives R. P value is 0, Q value is 0, that gives you 1. 0 and 0 is 0, carry down that one as it is, gives 1. So 0, 1 means 1, because if P is Only when P is 1 and Q is 0 will give 0. In all other cases it is 1. Next problem. P gives Q. If P then Q, then that gives you negation of R. P value is 0, Q value is 0, R value is 1, therefore the negation of R will be 0. First we have to solve the inner bracket problem. So 0, 0 will give you 1 as per the conditional truth table. 0, 0 gives 1. 0, 1 will give you 1. Let us move to the next problem. Construct the truth table for the following compound proposition. P and Q gives negation R. Okay, so we'll solve for this. We have 3 variables here, therefore we have to take it as P, Q, R. So the number of variables is 2 power the number of variables. Since we have 3 variables, it will be 8 different truth values you should get. 2 power 3 is 8, right? So it will be 8 different values. So all these 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. This is what you will get. First we will consider for P and Q. Then take the value of negation R. Then you consider, okay, till here will be your first problem. Till here will be your first problem. So P and Q, 0, 0 will give you 0, 0, 0 will be 0, 0, 1 is 0, 0, 1 is 0, 1, 0 is 0, 1, 0 is 0, 1, 1 is 1, because it acts like a multiplication. When both are true, then only true. 1, 1 is 1. Negation R. Wherever zeros, just put 1. Wherever 1, put 0. If here is 0, you have to put here 1. If here it is 1, you have to put 0. Similarly like that, 0 means 1, 1 gives 0, 0 gives 1, 1 is 0, 0 means 1, 1 gives 0. Nextly, as per our problem, you have to check for P and Q gives negation R. So these 2 columns we have to concentrate. 0, 1. So now we have to do is conditional statement. In conditional, if P is 1, Q is 0, then only 0. In all other cases it will be 0. So 0, 1 gives 1, 0, 0 gives 1, 0, 1 gives 1, 0, 0 gives 1, 0, 1 gives 1, 0, 0 gives 1, 1, 1 gives 1. Only when P is 1 and R is 0, then only it will give 0. In all other cases it is 1. So here, till here is your first problem. In the next second problem, you have Q and negation R implying P. So first we'll solve for this. As already we have taken a table for Q, we have to check for negation R implying P. If negation R, then P. So where is negation R? You have to consider this column and this P column. Okay, negation R is here implying P. So only when when it is 1 and 0, it will give 0. In all other cases it is 1. 1, 0 gives 0. 0, 0 gives you 1. 1, 0 gives 0. 0, 0 gives 1. 1, 1 gives 1. 0, 1 gives 1. 1, 1 gives 1. 0, 1 gives 1. So this you have to get to know. See the proper column and do the problem. Now let us discuss about tautology. What is tautology? A compound proposition which is true for all possible truth values of its components is called a tautology. Whatever the values you check for, all the possible truth values, you should get true. Answer should be true. Then we consider that as tautology. So, what is contradiction? A compound proposition which is false for all possible truth values of its components is called a contradiction. So, for all the possible values, if you are getting false value only, then that is called as contradiction. For all the possible truth values, if you are getting as true, then that is called as tautology. So, something else we have called as contingency. A compound proposition that can be true or false depending upon the truth value of its component is called a contingency. It can be either true or it can be either false, that we call it as contingency. So we have came across the many truth table which is consisting of truth and false values. Those comes under contingency. Note, contingency is a compound proposition which is neither a tautology nor a contradiction. All values will not be true and all values will not be false. It will be a mixture of both. So contingency doesn't come under tautology or in the contradiction. So now let us see the problems and check whether it is a tautology or contradiction. If you are getting the result 0, 0 only for all the possible values, then you can conclude it as contradiction. And if you are getting the result in terms of ones, then that we call it as tautology. Now let us see the first problem. Prove that for any proposition P or negation P is tautology and P and negation P is a contradiction. We have to prove that P or negation P is tautology and P and negation P is contradiction. Now let us take P and negation P. Okay. So if P is 0, negation P will be 1. If P is 1, negation of P will be 0. P or negation P, or means disjunction works like a addition. 0, 1 gives you 1, 1, 0 gives you 1. So for all the possible values, you got the result as 1. Therefore, P or negation P is a tautology and P and negation P. For 0, 1, it is conjunction. Conjunction works like a multiplication. 0, 1 gives you 0. 1, 0 gives you 0. So for all the possible values, you got the result is false. Therefore, it is a contradiction. Hence proved. Now let us discuss the second problem. Show that for any propositions P and Q, the compound propositions, if P then P or Q is a tautology, and the compound proposition P and negation P and Q is a contradiction. We'll check for this statement. In the second problem, show that for any proposition P and Q, the compound proposition, if P implies P or Q is a tautology, and the compound proposition P and negation of P and Q is a contradiction. Same. First you have to take PQ, then required part is P or Q. So take P or Q. Then together we need P implies P or Q. So P implies P or Q. Till here will be your first problem. So the second problem, what you require is P already we have, negation of P also is not there. So we'll take here negation P, then negation P and Q have to take. So we have taken here P and negation P and Q. Same 0 0 0 1 1 0 1 1, these are the possible truth values. For these values we are going to check P or Q. Any one of the value is true, then true. So 0 0 is 0, 0 1 1, 1 0 1, 1 1 1. If P, then P or Q. So this P and P or Q we have to consider only when P is 1 and Q is 0. If it is here is 0, then only it will be 0. In all other possible ways it is hello. So here for this problem P or Q will be these values. First problem, P is 0, P or Q is 0, 0 0 gives 1, 0 1 gives 1, 1 1 gives 1, 1 1 gives 1. This is tautology. For the second problem, negation P and negation, first we have to consider this one, negation P and Q. Negation of P is nothing but for 0 it gives 1, 0 also gives 1, 1 gives 0, 1 gives 0. Negation P and Q. 1 0 gives 0, 1 1 gives 1, 0 1 gives 0, then 0 1 gives 0. Now again we have to take conjunction of P and negation of P and Q. So 0 0 will give 0, 0 1 is 0, 1 0 is 0, 1 0 is also 0. So from this we can conclude that the first problem given is tautology, and by this result we can conclude that it is a contradiction. Given statement is hence proved. Now let us discuss about the third problem. Prove that for any proposition P, Q, R, then the compound preposition P, if P then Q then R, gives P then Q then P of gives P implies R. So such a big statement, what we have to do is, first, how many variables are there? 3 variables. 2 to the power of 3. How many possible ways values will be there? 2 to the power of 3 means 8. So 8 possible ways you have to get. So this will be there 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. Next thing is we need Q implies R. So first we have taken for all the 3 values P, Q, R, then Q implies R. Then what else we need? Then all together we need P implies Q implies R. So that we have taken here. Then P implies Q we have taken, P implies R we have taken. Then we have to take P implies Q, then P implies R. That we have to take. At the end, whatever the result you got, that we have, or all together we have to take it as this will be your P later, this will be your Q. Okay. So these are the possible values. Q implies R. For the conditional, what is the condition? If P is 1, Q is 0, then only 0. In all other cases it will be 1. Q implies R. Only these 2 columns you have to consider. 0 0 gives 1, 0 1 gives 1, 1 0 gives 0, 1 1 gives 1, 0 0 gives 1, 0 1 gives 1, 1 0 gives 0, 1 1 gives 1. Then P implies Q implies R. 0 1 gives 1, 0 1 gives 1, 0 0 gives 1, 0 1 gives 1, 1 1 gives 1, 1 1 gives 1, 1 0 gives 0, 1 1 gives 1. Next we have to check for P implies Q. Similarly, only when 1 and 0 it will be 0. In all other cases it is 1. So here P and Q we have to consider. 0 0 gives 1, 0 0 gives 1, 0 1 gives 1, 0 1 gives 1, 1 0 gives 0, 1 0 gives 0, 1 0 gives here 1 1 gives 1, 1 1 gives 1. Then we have to check for P implies R. We have to consider only P and R here. So 0 0 gives 1, 0 1 gives 1, 0 0 gives 1, 0 1 is 1, 1 0 is 1, 1 0 is 0, 1 1 is 1, 1 0 is 0, 1 1 is 1. Then now what we have to do is P implies Q implies P implies R. So now this will be our P and this will be our R. Only these two columns we have to consider. 1 1 gives 1, 1 1 gives 1, 1 1 gives 1, 1 1 gives 1, 0 0 gives 1, 0 1 gives 1. Only when 1 and 0, for that it will give 0. All other cases it is 1. 1 1 gives 1. Now we have to consider this part and this part. This will be your P and this will be your Q. 1 1 gives 1, 1 1 gives 1, 1 1 gives 1, 1 1 gives 1. For all same, 0 0 also gives 1. Remember, for condition, if P is 1 and Q is 0, then only 0. In all other cases it is 1 only. So hence it is a tautology. Now let us move for the next problem. Prove that for any proposition P, Q are the compound proposition, P or Q and P implies R and Q implies R is a tautology. Same. How many variables? 3 variables. So P, Q, R you have to take. How many? 2 to the power of 3 means 8. 8 possible values you should get. So these are the values 0 0 0 0 0 1 0 1 0 and so on. P or Q, P implies R, Q implies R. Then we have to consider the innermost part first. P implies R and Q implies R, that we have to take. Then P or Q and P implies R and Q implies R. Okay, so that we have to take. Means this one and this one you have to take here. Later, all together with R, if you take, that will be your resultant value. Same like before problem. This is the answer. Try on your own first, and it is a tautology. So the fifth problem is prove that P exclusive disjunction Q or P biconditional Q is a tautology. PQ, P exclusive disjunction Q, and what else we need? We need P biconditional Q. Then P by this one we have, this also we have, this also we have. Only need is P implies Q, right? So the for this the answers will be, let us take for this first problem. PQ, you know that 0 0 0 1 1 0 1 1, these are the values. For what is the, do you remember the exclusive disjunction means either of the things should be true. Both cannot be true, both cannot be false, right? Then only it will give true. So if it is 0 0, it will give 0. 1 1 gives 0. If any of the one is opposite, it will give you 1 1. Biconditional is opposite to that. Both should be same, either true or false, it should be same, then only it will give you the true values. For 0 0 it will give 1, 1 1 will give 1. For other cases it will be 0. P implies Q. Only for 1 0 it will give 0, all other conditions it will give 1. Right? Now in first case we have to check for P exclusive disjunction Q or P biconditional Q. So our problem will be like we have to check for this one and this one. We have to do the disjunction we have to do. So 0 1 gives 1, 1 1 gives 1, 1 1 gives 1, 0 1 gives 1, because it acts like addition. Therefore for disjunction all we got is, so from this result we can say that first one is a tautology. Second one, we have to check for P exclusive disjunction Q and P biconditional Q. P exclusive disjunction, so this column, and P biconditional Q, this column we have to check. So what it will give? 0 1 will give you 0, 1 0 gives 0, 1 0 gives 0, 0 1 gives 0, because your conjunction will act like a multiplication. Any of the opposite values it will give you 0. So our resultant value, everything is 0 for all the possible true values. Therefore it is a contradiction. In third case, have to consider P exclusive disjunction Q and P implies Q. Okay. Here we have to consider this one. Conjunction. What operation we have to do? We have to do conjunction operation. Means kind of multiplication. 0 1 gives 0, 1 1 gives 1, 1 0 gives 0, 0 1 gives 0. So here from this result we can see to that it has both true and false values. So it is neither a tautology nor a contradiction. Therefore we call it as a contingency. It is a mixture of both true and false values. Okay, thank you.